Let's talk a little bit about the unit circle. So circle, it's a word most of you are probably familiar with. Remember, mathematically, we always define a circle as having, if we can say where its center is and where its radius is, we've defined the circle mathematically. So the unit circle is always going to have its center at 0, 0, right? So you can see, I've drawn on the x-axis, I've drawn on the y-axis, right? And 0, 0 is right in the middle there. Okay, so it's got its center at 0, 0. Now, the unit part means that it has a 1 unit radius. Okay, so the distance from the center of my circle to the outside of my circle, that distance is 1. Okay, now just to sort of remind ourselves graphically, right, that also means that from here to here is 1, right? Anywhere from the center of the circle to the outside, any of those values, that distance is going to be 1. So just if we kind of wanted to write down an equation for this circle, if it's a circle centered at 0, 0 with a radius of 1, you can kind of remember that it has that equation, right? A circle centered at 0, 0 with a radius of 1. That's the equation for the unit circle. Now, on this unit circle, we're often going to talk about sort of angles that certain, points along this circle, right? We're going to sort of consider what angle, maybe I'll put this in, what angle this angle might make with the x-axis. There we go. Okay, so we're always sort of interested in this angle sort of in here. Right? What is that angle? Okay, so let's start. I'm just going to highlight this because we're always going to be sort of interested in that part there. Okay, so let's start by talking about this line here, right? So the green line and the yellow line, the angle that they have with each other, right? That angle, oops, that angle is 0 degrees. Okay. Now, if I were to go through and think about, let's do this line here, okay? So this line here, again, I'm thinking about this angle sort of in here between those two lines. That angle there is a right angle, right? So we talked about how that angle is 90 degrees. We're just going to do this in degrees first for a second, okay? Now, if I'm talking about this line here, right, again, if we're talking about sort of this angle in here, that angle there is 180 degrees, right? It's 290 degrees. 2 times 90 degrees is 180 degrees. So let's go in and write that in, that this is 180 degrees, okay? If I'm going down to here, right, so we've gone all the way around the circle to here. That angle is 390 degrees, right? 190 degrees plus another 90 degrees plus another 90 degrees. So 3 times 90 degrees is 270 degrees. So let's go in and write that in down here. Okay. And if we go all the way around, back around to this line here, right? We've gone 490 degrees, which is the same thing, sorry, I'm jumping around a little bit here, as 360 degrees. Okay. Now, from here, I kind of want to start, actually, let's fill in these angles here. So this angle here, okay, right? That angle, I've tried to draw it so it's exactly halfway between 0 and 90 degrees, right? So exactly halfway between 0 and 90 degrees is 45 degrees, okay? Now, the other two angles there might not be so obvious unless you maybe had like a protractor to go through and measure those angles, but I've tried to draw them on here, the special angles 30 degrees and 60 degrees, because those come up all the time, okay? We have special triangles that deal with those angles, and they're sort of ones that come up often. So I want to make sure we have those labeled. And we could go through and sort of label all the other sides with the sort of corresponding degrees and angles, but I really want to start moving towards the units of degrees, or of radians. So just like, let's say, if you're measuring a distance, right, you can give your height in feet, or you could give your height in inches, or you could give your height in meters, right? All of those are sort of measures of height. It doesn't actually matter what units you use. They mean the same thing, right? But, you know, some people might be more comfortable in one unit than another, right? And so I want to start moving towards getting more comfortable with radians, because radians is the primary units they're going to use for angles in most calculus classes here at UC Davis. So the sooner we get comfortable with radians, I think the better. So let's talk a little bit about that. So if I'm thinking about this angle here, the 0 degrees, we're kind of lucky. That angle there, if I were to talk in radians, is also 0 radians. Okay. Now, if I move around and talk about this angle here, right, so going all the way from here to here, okay, 180 degrees is the same thing as pi radians. That's our conversion factor. So when I go through, I can go through and label this angle here as pi radians, okay? So if I were to kind of go back and go all the way around to here, right, I have now gone around 2 pi's, right? There's 1 pi, there's another pi, okay? So I could go back in and label this angle here going all the way around as 2 pi, okay? Now we better go in and sort of fill out the rest of the angles. So this 90 degrees, right here, okay, that's only halfway to pi, which is here, right? So if we've only gone halfway to pi, right, we've gone 1/2 times pi, which if I wanted to write that in, 1/2 times pi, usually we just write as pi divided by 2. Okay. If I want to go all the way around to here, I've gone 1 pi over 2, another pi over 2, so 2 pi's over 2, 3 pi's over 2. Okay, so I can label this here as 3 pi over 2. Just bear with me, I'll move it back up. Here we go. Okay, so we've kind of labeled all of the points: 0, pi over 2, pi, 3 pi over 2. Now let's go over here to, oops, this is still green. Let me get rid of it. Gotta zoom in, get rid of it entirely. Go away. There we go. Okay, we're back. All right, so if I wanted to go here to 45 degrees, right? Remember that this angle here is pi over 2, right? Or 1/2 pi. Half of that, half of pi over 2 divided by 2 gives me pi over 4, right? So let me go in and label this angle here as pi over 4, right? You also might remember the relationship between those two angles from when we talked about the special triangles, okay? And the kind of corresponding angles here, right? This was, oops, this was 30 degrees was the same thing as pi over 6, okay? And that kind of makes sense, and I want to talk about why. So, right, from here to here, we're saying that this distance is pi over 6, right? And if I can sort of think about dividing up that pi, right, from there to 180 degrees in 6 equal size pieces. Bear with me, I didn't use a protractor to draw this, so they might be not exactly perfectly equal, okay? But if we sort of think of those as being sort of each of them being 1/6 of a pi, right? then I can actually go through and count, right? So if this angle here is pi over 6, right? Then this angle here would be 2 pi's over 6. So some people might write in 2 pi's over 6. Now, most people would simplify the 2 over 6 to be pi over 3. And that might sort of remind you of, you know, we saw that relationship before when we were talking about the special triangles. Okay, now this angle here, that would be 3 pi over 3, or 3 pi over 6, sorry, which is the same thing as pi over 2, so we already have that one. This one would be 4 pi's over 6, so let's go in and label that one. So that one would be 4 pi's over 6, which most people would simplify to 2 pi over 3, okay. This one would be 5 pi's over 6. So I can label that one. That one doesn't simplify anymore. Okay. Then this one here is 6 pi over 6. 6 pi over 6 simplifies to the pi, so I'm not going to write that in. And let's keep going around and label in the circle. So this angle here, right, that's going to be 7 pi's over 6. So we can go down and label it. So we've got 7 pi over 6. If I go one more, that would be 8 pi over 6. So I could label that. Now 8 pi over 6 simplifies to 4 pi over 3. Okay. Then from there, next comes, okay, so we did 7 pi over 6, 8 pi over 6. There's 9 pi over 6, which simplifies to the 3 over 2. There's 10 pi over 6. So we can label that one. 10 pi over 6, which most people would rewrite as 5 pi over 6. Okay. Then we get to here. That would be 11 pi's over 6, which doesn't simplify. And if we go all the way back around, then we get to 12 pi over 6, which is the same thing as 2 pi. So I kind of like working with this because I'm a fraction lover, but it's not so bad if you can just kind of go around and count out the pieces. The next piece that we should probably talk about is, so we know that this one here, right, is, this angle here is the 45 degrees or the pi over 4, right? So we can think about dividing this pi into pieces about that size, right? So there's a pi over 4. There's a 2 pi over 4 right there. Here is going to be 3 pi over 4. So let me go in and label that one. Okay. So this one here is 3 pi over 4. Okay. Then we've got 4 pi's over 4, which is the same thing as pi. This one here is going to be, you guessed it, 5 pi over 5, or 5 pi over 4. Perfect. Then we've got 6 pi over 4, 7 pi over 4. So let's label that one. And then all the way back around to 8 pi over 4. Okay, so we've kind of gone through, we've labeled all the angles around that circle, definitely all of them in radians, and I'm going to go in and fill in the angles in degrees.